Concrete is one of the most common materials on Earth, surrounding us in roads, buildings, bridges, and countless structures we depend on every day. But after it is poured, shaped, and smoothed out, something important happens that most people never actually see. The surface may look finished, yet deep inside, a slow transformation is still taking place. The difference between strong, long-lasting concrete and one that fails early often depends on this hidden stage. So why does concrete need a curing phase, and what exactly happens during this process? It is not simply about waiting for it to become hard, because concrete is still changing even after it appears solid. Let's get into it, right here, on History of Simple Things. To understand curing, we first need to look at what concrete actually is. Concrete is made from cement, water, sand, and larger materials like gravel or crushed stone. The cement is what binds everything together, but it only gains strength through a chemical reaction called hydration. When water interacts with cement particles, new compounds form and create the hard structure that gives concrete its durability. This process does not happen instantly, even if the concrete appears solid after a short time. The material continues changing internally for days and even weeks. Curing provides the conditions needed for hydration to continue, allowing the concrete to reach its intended strength instead of becoming weaker than expected. A common misunderstanding is that curing simply means letting concrete dry. However, concrete does not become stronger by losing water. In fact, losing moisture too quickly can create serious problems. As concrete dries, it naturally shrinks slightly. If the outside dries faster than the inside, uneven shrinking creates internal stress that may lead to cracks. This is why freshly poured concrete is often covered with plastic sheets, damp materials, or special curing compounds. These methods help prevent excessive evaporation and keep enough moisture available for hydration. The purpose of curing is not to remove water, but to carefully control it while the concrete continues developing. Temperature is another major factor that affects how concrete cures. Since hydration is a chemical reaction, it changes depending on the surrounding conditions. When concrete becomes too cold, the reaction slows down, and strength develops more gradually. In extreme cases, freezing temperatures can interfere with the process and damage the concrete before it has enough strength to protect itself. When temperatures become too high, moisture can disappear too quickly, creating the risk of weak areas and surface cracks. Builders often adjust their approach depending on the environment where the concrete is placed. In hotter regions, workers may keep surfaces moist or use protective coverings. In colder conditions, they may use insulation or heating methods to maintain a stable temperature and help the concrete continue curing properly. The importance of curing becomes clearer when looking at how concrete performs over many years. Properly cured concrete is usually stronger, more durable, and more resistant to cracking caused by weather, pressure, and everyday wear. Poor curing may not create obvious problems right away, but small weaknesses can slowly appear as the structure ages. Roads, foundations, bridges, and buildings all depend on concrete that was given the right conditions during its early development. A structure's lifespan is influenced not only by the materials used or the design created, but also by how carefully the concrete was allowed to mature after being placed. The amount of time needed for curing depends on the type of concrete and the environment around it. For many common mixtures, a curing period of around 7 days is often recommended, although strength continues increasing beyond that point. Engineers commonly test concrete strength at 28 days because this provides a standard measurement for comparison. However, this does not mean concrete stops improving after 4 weeks. Different mixtures, additives, temperatures, and construction methods can change the rate of strength development. Some specialized concrete mixes are designed to gain strength faster, while others are created to gradually become stronger over a longer period. Modern construction has introduced many techniques to make curing more effective. Traditional methods, such as keeping concrete damp, are still widely used, but newer approaches have also become common. Curing compounds can create a protective layer that reduces moisture loss, especially in large projects where constant monitoring is difficult. Engineers can also adjust concrete mixtures with additives that improve performance and durability. Even with these advancements, the basic principle remains unchanged. Concrete needs time, moisture, and proper conditions to fully develop. The curing phase is not an unnecessary delay, but a crucial part of creating a reliable structure. Concrete curing shows that some of the strongest things around us are not created instantly. A material that appears finished may still be quietly transforming beneath the surface, building strength through processes we cannot see. The waiting period is not simply a pause after construction, but a necessary stage where the material becomes what it was meant to be. Every bridge, road, and building depends on this hidden transformation, where small decisions during the early stages can determine how well something survives for years. It is a reminder that strength is not always about speed or appearance, but about giving the right conditions for something to fully develop. Thank you for watching. If you have suggestions for our next video, feel free to share them in the comments below. We'll be sure to give you an acknowledgement for your contribution. Thank you for joining us on this journey through the history of simple things. Don't forget to like, subscribe, and stay tuned for more stories woven through the smallest details.